Alright, 11 and 12 are probably the last ones I'm going to do. The rest of them are just done just like 11 and 12. And plus they're just like the assignment we did yesterday. So for 11 it says the speed in miles per hour of a tsunami can be modeled by the function, and this is the speed in miles per hour, and d is the average depth of the water over which the tsunami travels. Find the depth of the water in feet if the speed of the tsunami is 150 miles per hour. Nearest foot. That means rounded off the nearest whole number in this case. Alright, what I asked you to do was to write your equation out. I'm going to go ahead and just write S instead of SD. And we're going to have 3.86 square root. And D is what we're looking for. D is what we're looking for. So we have to move. Oh, sorry. D is what we're looking for. So we are given the speed, which is 150. So we're going to go 150 equals 3.86 the square root of D. Now I have to isolate the square root. To isolate the square root, I divide by 3.86. Once I divide by that, I get 150 over 3.86, and that gets me the square root of D. And yeah, I'm leaving this like this because I don't really feel like writing a long decimal out or anything, so I'm just going to leave it like this until I'm done. Now that the square root is isolated, let me switch colors so we can see what's happening here. I'm going to square this side and square this side. So D now, because that cancels and that cancels, is going to be 150 over 3.86 squared. I don't know what that number is. Instead of doing all that math, I can just plug that in as you see it in the calculator. So in the calculator, I'm going to go ahead, I'm going to put some big parentheses in, and I'm going to do alpha y equals, and get a fraction. I'm going to say 150 over 3.86, close my parentheses, and square it. I press enter. It gets me 1,510.1. We round to nearest foot. Nearest foot's at 0. So 1 tells that 0 to stay the same. So we have 1510. 1,510. Reasonable domain for the situation. Domain's something we're putting in. Reasonable domain, I would say, can you have a depth of less than 0? No, so the domain can be 0 to however fast you can go. I don't know how fast a tsunami goes. Let's just take it as that's the fastest it can go, and that needs to go to what is my D for this? Whatever it is, I don't know how fast it's supposed to go, so that's my best guess. 12. The radius of a right circular cylinder with a height in h and the volume of V is given by the formula. Use the formula to solve for V when r is 2 centimeters and h is 3 centimeters. What did I tell you before? Please write the formula for you. R is equal to the square root of V over pi h. Plug in what we know. We know R is 2. 2 is equal to the square root. H is 3. We're going to solve for V. So V is going to be the same. There's pi. H is 3. My square root is already by itself, so I can go ahead and square both sides. 4 is equal to V over, I'm going to switch that to be 3 pi. To get rid of 3 pi, multiply both sides by 3 pi. So I have V over here by itself. 3 times 4 is 12. I need my pi. So V is equal to 12 pi. That, of course, is an answer. If it wants decimals to estimate the answer, I can do 12 pi in the calculator, and I get that V is approximately equal to, say around anywhere, to 37.7.